Question 1. A machine learning model shows excellent performance with 98% accuracy on its training dataset, but achieves only 60% accuracy on a new, unseen test dataset. What problem is this model most likely exhibiting? Option A. Underfitting. Option B. Optimal fit. Option C. High bias. Option D. Overfitting. The correct answer is overfitting. Here's the explanation. Overfitting occurs when a model learns the training data too well, including its noise, leading to high performance on training data, but poor performance on new, unseen data. Question 2. Which of the following describes an underfit machine learning model? Option A. High training accuracy and significantly lower validation accuracy. Option B. Low training accuracy and similarly low validation accuracy. Option C. Good and comparable performance on both training and validation datasets. Option D. A model that has learned the noise and outliers in the training data. The correct answer is, quote, low training accuracy and similarly low validation accuracy. Here's the explanation. Underfitting happens when a model is too simple to capture the underlying patterns, resulting in poor performance on both the training data and new data. Question 3. Which technique is specifically designed to combat overfitting by adding a penalty term to the loss function that discourages overly complex models? Option A. Feature engineering. Option B. Cross-validation. Option C. Regularization, e.g. L1, L2, dropout. Option D. Increasing model complexity. The correct answer is regularization, e.g. L1, L2, dropout. Here's the explanation. Regularization techniques like L1, L2, and dropout are designed to prevent overfitting by penalizing model complexity or randomly deactivating neurons, forcing the model to generalize better. Question 4. Which of the following best describes why feature engineering is often considered the most critical step in the machine learning pipeline? Option A. It automates the selection of the best machine learning algorithm for a given problem. Option B. It directly creates new input features from raw data to improve a model's predictive power. Option C. It optimizes the internal parameters of a machine learning model during training. Option D. It primarily focuses on reducing the dimensionality of the dataset without adding new information. The correct answer is it directly creates new input features from raw data to improve a model's predictive power. Here's the explanation. Feature engineering is defined as the art and science of creating new input features from existing raw data to improve the model's predictive power. The study material emphasizes it often has a greater impact than algorithm choice or hyperparameter tuning. Question 5. A data scientist is preparing a dataset that includes a customer_city column with hundreds of unique city names. For a predictive model, they decide to replace each city name with the average churn rate of customers from that city. What type of categorical feature engineering technique is being applied here? Option A. One-hot encoding. Option B. Label encoding. Option C. Frequency encoding. Option D. Target encoding. Mean encoding. The correct answer is target encoding. Mean encoding. Here's the explanation. Target encoding, mean encoding, involves replacing a categorical value with the mean of the target variable, in this case churn rate, for that category. This is exactly what is described. Question 6. In a cloud environment, which managed service is specifically designed to provide a centralized repository for sharing, managing, and serving curated features consistently for machine learning models, both for training and inference? Option A. AWS Glue. Option B. Azure Data Factory. Option C. Google Cloud Vertex AI Feature Store. Option D. AWS S3. The correct answer is Google Cloud Vertex AI Feature Store. Here's the explanation. The study material explicitly mentions Feature Store as a centralized repository for sharing, managing, and serving curated features, and lists AWS SageMaker Feature Store and Google Cloud Vertex AI Feature Store as examples. AWS Glue and Azure Data Factory are ETL services, and AWS S3 is object storage. Question 7. What is the primary goal of model evaluation in the machine learning lifecycle? Option A, to collect and prepare raw data for training. Option B, to train the model on the entire dataset to maximize accuracy. Option C, to assess how well a trained model generalizes to unseen data and performs its intended task reliably. Option D, to automatically deploy the model to a production environment. The correct answer is to assess how well a trained model generalizes to unseen data and performs its intended task reliably. Here's the explanation. Model evaluation's main goal is to determine the model's performance, accuracy, and reliability, especially its ability to generalize to data it hasn't encountered during training, ensuring it's fit for purpose before deployment. Question 8. In the process of data splitting for model evaluation, what is the specific purpose of the test set? Option A, to train the machine learning model. Option B, to tune hyperparameters and select the best model architecture. Option C, to provide a final, unbiased assessment of the chosen model's performance on completely unseen data. Option D, to perform initial exploratory data analysis and feature engineering. The correct answer is, quote, to provide a final, unbiased assessment of the chosen model's performance on completely unseen data. Here's the explanation. The test set is reserved for a single, final evaluation of the model after training and validation are complete. It provides the most realistic estimate of how the model will perform in a production environment on new, real-world data, ensuring an unbiased assessment. Question 9. For a classification model, which evaluation metric is most critical when the cost of false negatives, missing actual positive cases, is very high, such as in medical diagnosis for a serious disease? Option A, accuracy. Option B, precision. Option C, recall, sensitivity. Option D, F1 score. The correct answer is recall, sensitivity. Here's the explanation. Recall, sensitivity, measures the proportion of actual positive cases that were correctly identified by the model. True positives plus false negatives. When false negatives are costly, e.g., failing to detect a disease, maximizing recall is paramount, even if it means accepting a higher number of false positives. Thanks for watching. Please subscribe to my channel.